Hi, and welcome to third lesson in thermodynamics. Today we're just going to be talking a little bit about heat flow. We're going to be introducing an idea called thermal equilibrium, and finally we're going to do this thing called the Zeroth law of thermodynamics, which doesn't really say anything, but you kind of need to put it. So what is heat flow? Heat flow is wherever thermal energy is moving out of one thing into another thing. So if you remember when I was talking about entropy, I used the idea of an ice cube and a hot cup of tea in a room. So just put them on a table here, representing that in a room. They both want to be at room temperature so that entropy can increase, because entropy always increases. So what's going to happen? Well, from the ice cube's point of view, heat energy is going to flow from the room into the ice cube, and it's slowly going to heat up until it's the same temperature as the room. However, heat energy is going to flow out of the cup of tea into the room until it too is the same temperature as the room. So even though both of these are becoming room temperature, one of them is doing it by heat energy flowing from the room into it, and the other is doing it by heat energy flowing out of it into the room. They will continue to do this until all of them are the same temperature, at which point we say they are in thermal equilibrium. However, thermal equilibrium is not actually defined as things being the same temperature. It is defined as the same amount of heat going in and out. Let us consider a nail held in a flame. We should know by now the nail will not just keep heating up forever and ever and ever. Eventually it will just cap out at a certain temperature. The reason for this, as good physicists like yourself should know, is the hotter it gets, the more heat energy it's giving off into the room, because the amount of heat energy we give off is proportional to the difference between background temperature and the object itself. Hot cups of tea cool down much faster when they're very hot than when they're nearly at room temperature. Liquid nitrogen will heat up much faster than an ice cube. So, we put the nail into the flame, and initially it's not in thermal equilibrium because more heat energy is going in than coming out, and that's why its temperature will increase and increase. However, at a certain point it will be losing as much heat energy every second as is coming in. The Q going into the nail and the Q coming out of the nail will be the same, and at that point we say the nail is in thermal equilibrium. The heat going in is equal to the heat coming out, which is weird because it's a nail in a flame, and you might not think that would be in thermal equilibrium. It's pretty hot. But that's how we're defining it in terms of thermodynamics. All of this leads us on to the so-called Zeroth law of thermodynamics. This is one of those laws which is a bit like one of those axioms in maths, like a plus 1 equals 1 plus a. You need it, but it's not that useful. The Zeroth law works like this. It says if you have two systems and they are both in thermal equilibrium with a third system, then these two will also be in thermal equilibrium. i.e., if the Q's in and out of these two are constant, and the Q's in and out of these two are constant, then the Q's between these two will also be constant. Now that's not that difficult to understand, really. If these two are the same temperature and these two are the same temperature, then these two will also be the same temperature, which would be fine if we were defining thermal equilibrium in terms of temperature, but because we're doing it in terms of Q flow, we have to define it this way. It's kind of just saying if you've got two things which are the same temperature and they're both the same temperature as a third thing, then all three things will be the same temperature, which isn't really saying very much, but you kind of need to put in there to make the rest of thermodynamics work. It's one of those ideas which is so simple as to trip one up, so just be a little bit careful about that. Cool. Some questions underneath. I'll see you next week.